This is video 4, and it has to do with finding the area of a parallelogram. It's the problem of the day. Parallelogram, formula, plug-in, answer, label. I also want you to do, as a problem of the day, number 17 on page 30. It looks like this. It's a trapezoid. So formula, plug-in, answer, label. 2 problems for the problem of the day, one on page 30 and this one on page 31. You can find the area of an irregular figure by dividing it into familiar figures, then adding the area of those parts together. There are often several ways to divide the irregular figures. So this example here, first way they divided it is into a rectangle, and a triangle. So 1 is a rectangle, 2 is a rectangle, 3 is a triangle. Another way you could cut it, going horizontally, you could have it as a rectangle 1 here, rectangle 2, and triangle 3. So a couple ways that you could cut that one, and you'll see I'm going to do that in the video. Find the area of this figure. Well, the easiest way to do it is say, oh, well, I draw that line there, and you can see they did that. They made it into a triangle plus a rectangle. So the triangle is 8 by 5, and the rectangle, right, is base times height 6 by 10. So if you add the half of the base times height, triangle, and rectangle together, you get 80 feet squared. This is a second example. So here's number 2. Find the area of this figure. Well, this looks kind of like a house, and it has a roof, which is triangular. So I'm going to split that into a triangle plus a rectangle. So area equals triangle plus rectangle. Now I do it all as one. You can do triangle separate, rectangle separate, but I don't want work all over the place. This way it's together, more organized, neat. Make sure you're plugging in all the values. So here goes for the triangle. 1/2 base, well, the base obviously is 40, because this is a rectangle. This base is also 40. What's the height of this triangle? Box. Well, all of it from top to bottom is 20. Here's 15 of it, so this little piece from here to here must be 5, right? Because 15 plus 5 makes 20. So that height inside here is 5 feet. So my base, 1/2, times my base of 40, times my height of 5, plus base times height, 40 times, or length times width in the rectangle. You could call it base times height. The base is 40, the height is 15. So half of 40 times 5, just go ahead and multiply across there, and you get 40 times 5 is 200. Half of that is 100, plus 40 times 15 is 600. I don't have to show this step. I could just say, oh, I'm just going to go ahead and multiply all the way across and add. Put it into your calculator. It is scientific. It will multiply first and then add second. That 100 and 600 is 700 feet squared. You can show that step 100 plus 600 and then 700 feet squared. Formula, plug-in, answer, label. All the parts have to be there. Next page, area of composites. Follow these steps to find the area of the irregular figure shown. Divide the figure into 2 rectangles. Find the area of each rectangle. Okay, well, easiest way to do it is right? Go down here. If all of this is 8 and this part is 5, then this part must be 3. So that's a square. So it's a rectangle plus a square. So area equals length times width plus side squared. I say side squared for a square. So my rectangle is 5 by 6, and my square is 3 by 3, or 3 squared, or 3 times 3 if you want to do it that way. Either way, still means 3 squared. So you get 30 plus 9 is 39 meters squared. Another way I could do this, another way I could have done this, I could have split it into this rectangle on the top and this rectangle on the bottom. That's another way I could have done it. So I could have a 3 by 5 rectangle and an 8 by 3 rectangle. 15 plus 24, oh, that's 39. Or yet another way, here's another way I'm going to show you. Think outside most. So I should really dot that. And I'm going to think, oh, what if I take this whole rectangle and subtract that square from it? I could do it that way as well. And how do I know it's a square? Because I know this part is 3 and this part is 3, because all of this side has to be 6, like its opposite side. So you could do it this way. Area equals rectangle minus square. I could do it that way. So outermost rectangle, 8 by 5, minus that little piece that really doesn't exist there, minus this little piece here, minus that square. So I get 8 by 6, silly. 8 by 6, which is 48, minus 9, which will give me 39 meters squared. So I showed you 3 ways on that example. Find the area of each shaded region. Well, I'm going to do it this way first. I'm going to take that little tiny rectangle over there on the side. If the whole thing is 26 and this part is 17, then this must be 9. So area equals length times width plus length times width. And I've got a 25 by 17 rectangle on the left there, plus that little tiny one is 9 by 6, right? Or 6 by 9, doesn't really matter. And you get 425 plus 54, which gives you 479 inches squared. Formula, plug in, answer, label. Another way I could do it is to cut it as area equals length times width plus length times width, and do it as a 26 by 6. So that's cutting it this way. What if I did this? So I have this rectangle on the top here and this one on the bottom. So I could do 26 by 6 plus 17, and since this is 6, this has to be 19, so 17 by 19, and 26 times 6 is 156, and 17 times 19, 323, 156 and 323. Oh, I better write that down so I can add that in my head. 323, or use a calculator, and you get, well, 479. Yes, of course you should get the same answer. Inches squared. So 2 ways to do that one. Ooh, it's kind of like a little crown or something. Number 6. I could do rectangle plus 2 triangles, right? I'll do that one first. Area equals rectangle plus 2 triangles, 1/2 base times height. So that 2 times 1/2 is going to cancel each other. And the rectangle is 35 by 15. 35 by 15 times 15 plus, these will cancel. The base of my triangles are 10. It's right there. And if this whole side is 25 and this part is 15, then this side has to be 10 as well. That gives you the whole. So base of 10 and height of 10. Oh, that's interesting. So base 10 times height 10. So 35 times 15 is 525, and 10 times 10 is 100. 525 plus 100, 625 meters squared. Another way I could do that problem, this is probably the harder way. Take the whole thing, think of it as this whole big rectangle, minus this trapezoid. This is a trapezoid right here. That part that's really not on the shape. But if I take the outermost, biggest thing that I can do, and then subtract the trapezoid, I'll get that area of just the shaded part there. So here's the OR. Area equals big outside rectangle minus trapezoid. Big outside rectangle is 35 by 25 minus half the height of that whole thing is, oh, trapezoid height. Trapezoid, oh, we know that's 10 because we already did that from the triangles there. So my height is 10 of my trapezoid, and my bases are 15 and 35. So I get 35 times 25, that's 875 minus, well, half of 10 is 5, 15 and 35 is 50, 5 times 50, that's 250. Okay, so 875 minus 250, oh yay, 625 meters squared. So 2 ways to do number 6. Number 8, a shaded region. So it looks like a rectangle with a triangle, well, 2 rectangles with a triangle. Ooh, the only way I can think of to do this one is do outermost rectangle. So do big outermost rectangle minus little rectangle that I drew in there, minus the triangle, right? And that will give you all the shaded part that's left. That's what I'm going to do. That's the plan that I have. So sometimes I do that. I write my plan out in English. Area equals length times width of the big one, the really big one. So I'm going to use capital L and capital W. Big outermost one minus little one that I drew in kind of on the dot corner here, minus triangle on the inside there. Okay, so big outermost is 70 by, well, if that's 30 and this is 20, this whole side here must be 50. Okay, so big one is 70 by 50 minus little one. Here is 20 by 20, that's 20, and this, if that's 40, then this has to be 30. They're telling me this is 20. So 20 by 30 minus the triangle. Oh, that's nice. They gave them to us. The base is 40. Half of 40 times 20. So 20 times 20. Well, I know that's 400. 20 times 30, that's 600. And 70 times 50, well, that's easy. They'll have zeros on them. That's 3500. So 3,500 minus 1,000 is 2,500 meters squared. 2,500 meters squared. And that's it for today's video. Be ready to recognize these shapes and come up with a plan to add, subtract, so on and so forth. It's going to be a tough day tomorrow.